Thank you very much, and thank you ahead for the interpretation services, because I'm afraid my Korean is not very good. Not at all. So thank you very much for having me this morning. I'm very, very happy to be here chatting with you about digital transformation. Again, my name is Cornelia Davis. I'm the CTO of our transformation practice at Pivotal. For the last 3 years, I've had the opportunity and the privilege to work with many, many large organizations in their digital transformation journey. And what I'd like to share with you today are an essential set of patterns that we have employed with those customers over the course of the last 3 years in helping them transform from being a company that maybe had some digital products to becoming a company that is a digital company and provides value to customers via those digital services. So what I'd like to do is I'd like to start with a few stories. Some of these stories you may have read about before, and all of these stories come to you from the United States, which is where I live. So you may all be familiar with the story of Blockbuster. Blockbuster was a DVD rental company, a movie rental company. And the customer experience, and I used to go to Blockbuster myself, was something like this. I would get into my car, I would drive down to Blockbuster, I would carry my DVD into the Blockbuster store, and then the first thing that I did was I would pay the late fee, because I was always late in returning my movies. After paying the late fee, I would select a new movie, I would drive home, and I would put it on the shelf where it would sit and I might watch it, and then 2 weeks later I would pay another late fee. Well, that experience has been changed significantly through digital products. And now the experience is Netflix. I sit at home on my sofa and I select a movie and I stream it live. Now, the thing that you may not remember is that the first value add for the customer that Netflix brought was the elimination of the late fee. They didn't bring streaming right away. They started with a very simple thing for customers, and that is to get rid of the late fee. And that was a significant value add for me. Another story that you may be familiar with, but I want to share a little bit more insight on, is the story of Borders. Borders didn't exist 20 years ago. They came in and they were a very disruptive company 20 years ago. They came up with the concept of a bookstore that was a social space. So rather than just being a place where you had rows and rows of books, when you went into a Borders, which was a very big, beautiful building, you found a coffee shop. You found a children's area where not only could you buy children's books, but you could play with your children. You could sit in very comfortable chairs, you could read books, and that changed the way that people went to bookstores. They socialized at bookstores. So 20 years ago, this company was very disruptive. 5 years ago, the company no longer existed because they did not become a digital company. They did offer some online, but they fundamentally did not become a digital company. Amazon, of course, came along. And Amazon provided even greater customer value. I had unlimited inventory, I had lower prices, I could see what other people were saying about the books that I was buying. So I could get recommendations from other individuals. That was a significant value add brought to me with a digital product. And then finally, we're all very familiar with the story of the transformation that's happening in the transportation industry. No longer do you need to stand on a rainy street corner to hail a cab. You can now use Uber, or the equivalent here in Korea, to order a car and sit inside and enjoy your coffee while you wait for the car to arrive. Now, all of these companies, Netflix, Amazon, Uber, have come in and disrupted the space. They've disrupted existing markets. And so you can ask the question of, what does it take to compete? How can a traditional enterprise not become tomorrow's story of failure, but actually become a disruptor themselves. And at the core of that entire thing is the ability to bring value to customers through digital products. Now, bringing value to customers through digital products is something that many of these companies don't know how to do. And as it happens, we're going to talk about what some of the things are that customers need to learn how to do to become software providers for customers. So I want to talk first about a little bit more about that continuous delivery of value to customers. So let's go back to Amazon. You may know this already, that Amazon releases software to their customers on average every second of every day. Now, I'm not suggesting that you all want to release your software every second of every day, but by the end of these 40 minutes, I hope that you'll be convinced that releasing software very frequently is an essential goal. So you can ask the question of, well, okay, Amazon does it every second of every day. Why? Well, let's take a look at something here. Over time, when you are creating a software product and releasing it to the market, whatever time period it takes from the moment that you have an idea to the time that you bring that idea to your customers and hope with it to bring some value, you're going to be increasing speculation. So for example, when your marketing department comes up with a new idea of something that they want to bring to the customer, there's a certain amount of speculation involved. They think they know what the customer wants, and they write that down. They hand that over to the business analyst who evaluates that description and translates it into the requirements that are going to be written by the software developers, therewith adding more speculation. Then the software developers write the actual digital product, so they write the software, adding a bit more speculation. And then eventually we release the product, and now there's no more speculation. We know whether we built the right thing or not. We know whether customers like it or not. Well, the area under that curve is risk. And so if you take a long cycle, such as what we see here, you can see that you're taking on a great deal of risk. If instead we release software very frequently and we're doing very short iterations, it's not that we have less speculation. In total, the amount of speculation is the same. If you add up all of those curves, the total curve is the same. But because we're releasing, the area under the curve is much smaller. The risk that we're taking on is far, far less. So the reason that Amazon releases software very frequently is because they want to make sure that they're building the right products. They want to reduce risk. So it's all about that continuous delivery of customer value. So what are the obstacles to releasing continuously to the customer? Well, these obstacles are probably going to sound very familiar. You have silos in your organizations. So you have different organizations that you need to hand things off to, and there needs to be lots of approvals. Another thing that you might be familiar with is the notion that the developers have written the software and they've given it to the operations team, and the operations team says it doesn't work. And the developer says, well, it works on my machine, but it doesn't work on the production machines. So having different environments is a pain point. Deployments are treated as risky things. We do deployments at 2 o'clock in the morning or on Saturdays when we think there's no customers. But you know what? There's always customers now. There is no time where they're during off hours anymore. Changes in the environment are treated like an exception, and so you end up running around and fighting fires. So and that takes up a lot of time. And then we design a whole bunch of processes around those obstacles. Instead, to become a digital company, to become a software company, you need to get over those obstacles. And these are the 5 patterns that I want to spend the time today, the rest of the time talking about. We're going to reinvent the software value chain. We're going to change the way that the process that we go through in building software. A second essential pattern is a fundamentally different set of architectures. Your software needs to be designed in a different way, and I'll teach you how. You need the right platform to run that software on. Then you need the right practices around building and running that software in production. That's DevOps. And then you need to have a fundamental change in the mindset that I am not expecting things to stay stable anymore. As a whole, they need to stay stable, but all of the individual pieces are going to be constantly changing, and I need to expect that. And I'll talk to you about how we do that. All right, so let's talk about the first one of those, and that is changing the software value chain. Today, the way that most software is developed looks something like this. There's all of those different silos that I talked about: business, finance, project management, application development, quality assurance, operations, security, compliance. There's more than what you see here on the screen. A new project is created, and individuals come in and out of that project. So the business comes in and writes up the requirements document. That's handed over to finance, who fund that project. That's handed over to the project management office, handed over to development, and so on. So you can see that nobody's working together in the project at the same time, and there's a whole bunch of things that are just getting handed over the wall to the next organization. The worst part is that each one of those individual organizations have their own measure of success. And so let's look at 2 of these. Application development is often measured on whether they hit the schedule. They need to release the software, they need to write the software by May 31st, by a specific date. Now, quality assurance, they are measured on the number of bugs that they fix. Now, let's think about that for just a moment. What happens when a software development team is falling behind a little bit? They're maybe not going to meet their schedule. They start to take shortcuts. And in taking shortcuts, they often introduce more bugs into the software. But they're hitting the schedule. So they're rewarded for hitting the schedule. Now, the quality assurance department is rewarded for finding bugs. And you know what? The developers are creating bugs. So quality assurance is finding lots of bugs. So they're getting rewarded for finding lots of bugs. So each one of those individual organizations is being very successful, except that you could argue that they're not bringing a lot of value to the customer when they create software that has quality issues. So each one of these silos has their own measures, and that's a problem. What we do is we work with our customers to change that mindset. Instead of talking about projects and having individual silos, we recommend that you bring all of those different functions together into what we call a product team. So the product is the central thing. And all of those individuals are measured on the same thing. That's right. Are they bringing value to the customer? So if we go back then to, let's say, the Amazon case, where we say, oh, we've got all these different products that Amazon is creating, the teams are getting rewarded for doing a better job showing product images, doing a better job creating better recommendations for the buying process. And when the consumer finds the products that they need because the recommendations are better, that's customer value. So this is the first pattern, very, very essential. So the second pattern is, reorganizing your teams, absolutely critical. Number 2, you need to change the way that you write your software. Your software architectures are different. So this is the actual design of the software that I'm talking about. And we call these cloud-native software architectures, or you might have heard the term microservices. So let's go back to Amazon for a moment. If you remember, they release software on average every second of every day. Well, the whole of Amazon.com is not one application. It's in fact made up of a lot of different applications. So there's an application that is just serving images. There's another application that is providing recommendations. Another one that provides reviews, and another one that is the shopping cart and the purchasing experience. So all of those are different applications. And from an architectural perspective, very high level, here's all of those different products. And they all are brought together to create Amazon.com. Now, if you remember what we just talked about product teams, each one of those individual microservices is an individual product. So each one of those teams is responsible for their product and the value that they bring to their product. So what are the advantages of having these microservices, having this kind of architecture? Well, you can scale your applications better. So for example, if you need more search capacity, you can scale out more search capacity. Or if it is what we call in the United States Black Friday, the day after Thanksgiving, very big shopping day in the United States, you can scale out your shopping cart service to make sure that your customers can complete that transaction. But you don't have to worry about, for example, scaling out the reviews, because on Black Friday, people aren't writing reviews, they're frantically, very quickly buying product. So you can scale applications differently. It also allows you to scale your teams. Each one of those individual microservices has a team that has about 4 to 8 developers. So when you want more functionality, instead of creating a larger organization, you create a new microservice team, and you can scale that way. We all know that the larger an organization gets, the more communication overhead there is, and the slower things are going to go. You can have those things be independently released and have independent development cycles. Amazon doesn't release the entire Amazon.com every second of every day. On Monday, they might release a new version of the image service. On Tuesday, they might release a new version of the shopping cart service. They're all independently released. Doing so allows greater experimentation. It allows me to try things out with the recommendation engine without affecting the shopping cart. And in the end, by not having everything tightly coupled together, I end up with a more resilient system. So that if the image service has crashed, I can still complete my transaction with the shopping cart. So they're no longer tied together. Now, I won't spend a lot of time talking about these next 3 slides, except to say that in the old world, where we had monolithic architectures, that came with a certain amount of simplicity. One single monolithic application was one thing that I needed to manage. But now, when I have hundreds of microservices with hundreds of instances, that brings its own challenge. So I need to answer questions like, if I have 100 versions of my image service out there and I need to change a configuration setting, how do I do that? Or when the overall Amazon.com webpage needs to access the shopping cart service and the shopping cart service has moved, how does it find it? So there's all of these challenges that come with microservices, and I encourage you to look out in the industry. There are quite a number of articles that are written about these challenges. And the good news is that there are existing patterns for how you address those challenges. So there are things like configuration servers and configuration patterns specifically for microservices. There are service discovery that allows me to find a service even if it's moved, and things that allow me to monitor my services and keep cascading failures from happening. So those are the important things. So changing the fundamental architectures of your software. Now, the third thing is, when you change those architectures of the software, you have to change the platform that you run them on. The platforms we've been running on for the last 20 or 30 years, client-server platforms, are not suitable for these microservices architectures. So let me share a little bit about those platforms with you. Now, this is a chart that is not a chart that I created. It's a chart from a blog post, and you can see the URL there. It's from an O'Reilly blog post. And what it describes are two different companies. Those companies were bringing new digital products to market, and they both started at the beginning with nothing. Now, what you see in the chart is the amount of time that they spent working on things that were not building the digital product for the customer. So this is the non-customer value add work that was being done. So they're not writing software here, they're doing all of the other things other than writing software. Now, both companies at the beginning had to spend some time setting things up so that they could write the software and they could release the software. So they both spent a lot of time at the beginning, and then you can see that they both stopped spending so much time on that work and they started working on the software that was going to bring value to the customer. Then when the companies went live in production, the company on the left-hand side had to start spending a lot of time working on non-value created work. And the company on the right-hand side didn't. So what's the secret? What did they do on the right-hand side that they didn't on the left? On the left-hand side, they took a very traditional approach. They said, we need to stand up servers, and then they took a very traditional approach to operations. And so they operated things the way that we have been for the last 20 or 30 years in client-server models. The company on the right-hand side built a platform. They built a platform that supported this new software architecture and new ways of operating it. And they were able to keep that very flat. Now, one of the most interesting things about this slide is look at the date. This blog post is from 2007, almost a decade ago. So you can ask the question of why? Why isn't everyone doing this, doing what's on the right-hand side? And I give you two answers. Number one, there are a certain category of customers who are doing this. The companies who are disrupting the market, the Netflix, the Amazon, and the Uber, they have all done this. They've built those platforms. And in many cases, they built those platforms 10 years ago. Google, for example, built those platforms 10 years ago. The second answer is the reason that companies are not doing things on the right-hand side is that building platforms is hard. It's very, very difficult to build platforms in this new style for the cloud. That is one of the things that we have done here. Thank you. That is one of the things that we have done at Pivotal, is we have created the Pivotal Cloud Foundry product. Pivotal Cloud Foundry is a commercial distribution of an open source project called Cloud Foundry that's been around for 5 years. By the way, one of the other companies that built that platform I mentioned was Google. Cloud Foundry was initially created by 3 individuals that came directly from Google. These were the people who built the Google platform that came over and built the Cloud Foundry platform. So it's a native cloud-based platform. Now, this platform is not just a little bit different from the client-server models that I've talked about before. It's significantly different. In the client-server models, I'll put the emphasis on server. The emphasis on server. It's all about IT things. It's servers, it's compute, storage, and networks. The new platform puts the digital product at the center. It puts the application at the center, and it allows you to operate on that application. It allows you to deploy an application, scale an application, secure an application, not secure a machine that happens to be running an application, but to secure the application itself. So it's all about the application at the center. When you put the application at the center, it allows you to create a new organizational structure. Remember the product teams? Well, it allows me to create a product team that is responsible for the application. That's the team on the top. And they're responsible for building and operating that application. And I treat the platform as a product as well. The customers of the platform are the application teams. So the platform is absolutely an absolutely essential pattern for bringing new digital experiences and digital transformation. All right, let me talk about the fourth pattern now, and that is DevOps. So I just said that the application team is going to develop and operate an application. So they're doing both, dev and ops. Well, it does take a platform, and I'll talk a little bit about that, but let me talk about DevOps first. Let me very simply define that the part of the life cycle that we're talking about here is application through operations, dev through ops. Now, the way that the dev through ops cycle works today looks a little bit like this, very approval based. So the developers write the code, then they have to hand it to the security group who has to approve something, compliance has to approve something, QA has to approve it, they have to say, yep, this is of good enough quality. Operations then can run it in production. Change management has to approve things before we can put things out in production. All of those different functions need to request access to the infrastructure to be able to do their work. So you can see that the value chain here has lots of weight state in it. Well, if you use the right platform, watch what happens here. All of those functions in the orange, the functions in the orange are not creating customer value, but they're absolutely critical components. We need security, we need compliance, no question about that. But if we take those manual approval-based functions and we map those down into the right layers in the platform, we get to do something very, very clever here. We take those approvals and we transform them into more of an audit and automation process. And so let me share a story with you here. We have a customer that I've been working with for more than 3 years now, that they are a traditional IT organization, and before they can release code into production, they have to get a whole list of things checked off. By creating this model where they've taken security and compliance, they've built that into the platform, and a lot of it is built into the platform, and then you can customize it for yourself. By building it into the platform, they took that list of controls, the list of things that they needed to get approval on, and they got rid of half of them. They cut the approval time in half. That is very, very, very important in getting to continuous delivery. So having the right platform, and once you have the right platform with that stuff built in, what you do is you empower your development teams. Your development teams now get self-service instead of approval-based. Very important concept. Now, the fifth thing is probably the thing that is the hardest to wrap our heads around. It's the hardest thing to understand. And that is this notion that in this new world where we're bringing digital experiences today, change is not the exception, it is the rule. And what I mean by that is that we expected over the course of the last 20 or 30 years, when we wrote software, we expected the system to be stable, never changing. And if something went wrong with the system, then the software folks could say, wasn't my fault, the system went down. In this new era of cloud, the system is always changing. it doesn't stay stable. It's changing sometimes because something breaks. One of those commodity servers goes offline. Sometimes it changes because we have to upgrade something. An operating system vulnerability comes along, and I intentionally need to change the system. I need to change the version of the operating system. So change is the rule, not the exception. Now I'm going to talk about this from the perspective of three different areas. What do I need to do as a developer? What do I need to do as somebody who's operating code? And then what does the platform need to do? To get into this mode of change is the rule. Now, as a developer, I need to do these things. Number one, if your developers are not writing complete automated tests for your software, that's the first place to start. Because when things are changing, you cannot have manual tests that need to be run to make sure things are still working. So automated test suites is absolutely essential. The next thing is, going back to those architectural patterns, is that those microservices that we talked about need to be stateless. And that's because when I am shopping online and I add something to my shopping cart, and then I look at another product and I add a second thing to my shopping cart, in that time from the first ad to the second ad, something could have changed. And I could be going to a different server with my second request. So I need to design my application so that the state didn't exist on the first server, it's stateless, so that I can go to the second server and continue my shopping experience. I can also implement patterns, I won't go into the details, but things like circuit breakers and fallback behavior. What I mean by that is, if I'm a developer and I make a call to another function, if that function is unavailable, I still need to be able to work. So the shopping cart needs to work even if, or taking a credit card needs to work even if I can't show you what's in the shopping cart, because people maybe already know what's in their shopping cart. And there's a number of other patterns that you need to follow as a developer. As an application operator, you need to build up a new set of skills and a new mindset around those patterns. You need to do things like monitor those failure conditions in a different way. And again, you expect those. You're monitoring them not as a reaction, but you're monitoring them as a prediction. And that's also, by the way, where big data can really come in and help. When you start treating your IT data as a big data set, you can start using that to predict when things are going to go wrong. Another thing is that as somebody who's deploying code into production, you want to make that deployment far less risky. So what we've done in the past is we said we are going to test all of the things around deploying into production. We're going to spend a lot of time testing that in a staging environment before, and we believed, wasn't actually true, but we believed that by doing all of that testing ahead of time, nothing would go wrong in production. Well, we know that's not true, right? We do all this testing, we go into production, and something still goes wrong. So you have to expect that change. You have to expect that things to go wrong. And so you do things like blue-green deployments, where you have version 1 of your software running, you release version 2, and you run them both side by side. 90% of your traffic still goes to version 1, 10% to version 2. Ah, looks good. Maybe 80%, 20%, 50%, 50%. Uh-oh, something goes wrong. I can pull back and leave version 1 in production. So coming up with a set of ways of doing operations, expecting change and expecting things to go wrong is very essential. And then finally, I talked about platforms. So there's a term that we use called eventual consistency. All of these new platforms expect change. So instead of just describing everything that needs to happen and expecting that to go well, the way that these systems work is that as a user of the system, I express my desired state. I would like 5 instances of this application to be running. The system then is in the business of taking that desired state that you expressed and making the actual state of the system match. So if you say, I want to deploy 5 instances of the app, it says, great, I see there are 0, I'll give you 5. If one of those instances crashes, remember, things are changing all the time. If one of those instances crashes, the system says, oh, I only see 4, you said you wanted 5, and it adds a 5th one for you. That's the kind of behavior we need in our platforms. So to close out, here are some of the disruptors that we talked about. Uber, Amazon, Square in the financial services space. These companies are following these patterns and practices that I've described today. This is their secret sauce. This is how they are able to come in and disrupt things and change things. And the question that I ask is whether these large organizations can themselves be disruptors, or whether they'll become the borders of the next decade. These are all companies that we are working with Pivotal to help them transform into being digital companies. Thank you very much.